All right. Welcome, everybody. Hello, hello there. Great to see
Welcome.
everybody. Yes. Already see a ton of stuff in chat. If you haven't discovered it yet, there is a chat that you can send messages to on Zoom, and you might have a chance of having your message show up on the bottom.
Yeah, so to do that, just go into the chat on Zoom and you can kind of change who you're sending your messages to and make sure you're sending them to chat relay. So just to get some practice and warm up with this new skill, well, let us know where you're from and what's the coolest place you've been to.
All right. Jesse, where's the coolest place you've been?
Honestly, I think it's got to be Alaska. Because when I was in Alaska, we got to take a helicopter up onto a glacier, and then there were like a bunch of huskies up there, and we went like fake dog sledding. And that was like really
Whoa.
cool.
So you've been in the helicopter.
Yeah, the
Wow.
one time.
That's cool. All right. I'm
Yeah, where have
saying
you
yes.
been?
For me, coolest place I've been to China, been to been to Paris, and I remember once when I asked this question to students, they said my bed. So I definitely feel that one. All
Very
right.
valid.
In chat, I see a lot of US, a lot of China, so Canada, Toronto. Coolest place is Paris as well. Awesome. Ooh, coolest place is probably Hawaii or Lake Tahoe. Our West Coast friends would love that. I'm sure we know a lot of people who go to Lake Tahoe.
I see someone says the coolest place they've been to is Earth. So it's pretty general, but yeah, there's a lot of cool places on Earth.
I think it's
Good
a pretty
answer.
rad place. Yeah, pretty
Yeah.
rad place.
Although Mars is pretty compelling too.
Yes. Atmosphere is not, though. All right. The universe, also a pretty cool place. Oman. Been to Oman. That's awesome. That's, I think, a unique one here. Kalahari and Poconos. I've not heard of these places.
Ooh, I see someone says coolest place is Ohio. So I don't know if that's really such a cool place.
I can confirm it is not. It's Ohio. I mean, this is
Yeah,
cool. This is Ohio. This is pretty cool.
that's the one cool part of Ohio is where Eddie teaches from.
Absolutely. Yeah, this is very interesting. I have no idea how Ohio became a meme, but it is. Wait, this is fun. Florida man. We have Florida man in
We got
Ohio.
the two meme states.
Perfect.
Ooh, and that answered a question that came in chat. Where do we come from? So yeah, I am a Florida man, and Eddie is.
I'm from Ohio, specifically from Cincinnati. So we just lost to the Chiefs in football, if you guys follow that. Very sad, very sad.
Ohio. That's got like a nice flow to it.
Ohio. So it reminds me of
Oh
growing
my
up.
goodness. You guys are great. You guys are great. I have to say, I mean, this is indeed a great pair. We have Florida and Ohio. And I guess I'll say hello to everyone. Hi, I'm Po-Shen Loh from Pennsylvania, because we may as well slowly start to get started. So yes, this is the AMC 8 live solve. We're going to work on questions from the 2023 AMC 8, questions 1 to 15. Yes, hi everyone. And just in case you just came in, the reason that we were chatting for a while is because we want to give enough time for people to come in. And we also wanted people to get used to chat relay. So actually right now, the Zoom room it's not at capacity. So if you actually wanted to join, you're very welcome to join. We have moderators on YouTube and Zoom, by the way. So no matter where you're watching, or Facebook or LinkedIn, no matter where you're watching, you can participate with all of this. Okay, so again, if you are in the Zoom room, you'll notice you can only chat to hosts and co-hosts. Choose to send messages to chat relay, and then you'll be able to have your message maybe appear on screen. At this point, I want to tell you what you're about to see. You see, this is one of the fun things that we do, where we bring some brilliant high school students who actually have done a lot of math competitions before, and then they work on questions with me, and we take turns solving these questions, showing you how we think about the AMC 8. Now, let me introduce my co-hosts, maybe just in the alphabetical order by last name. Jesse, can you say something and then you'll appear on the screen?
Hi, everyone.
Yes, this is Jesse Brodman. He's incredible, and his shirts are also always hilarious. He's one of the people who teaches with us, and he's been teaching with us for a while. And in case you wanted to know, he's actually been around the block in mathematics as well. So he's the leader of a statewide math competition, and he's also placed top 6 in national math competitions. But he doesn't only do math, he also likes computer programming. And in fact, he has a perfect score from the USA Computing Olympiad Bronze Division. So the people that we have here, they have lots of skills, not only in math, and they're going to be very interesting to listen to. Also, we have Eddie. Eddie, can you say something to take over the screen?
Hello.
Yes, this is Eddie. Eddie's actually been with us for a very, very long time. And in fact, if you go to our website, you probably see Eddie. But let me say a little bit more about Eddie. So Eddie is also very, very good at math. I heard that there was a meme around his state, which has 4 letters that start with an O and end with an O, but he was the state math counts champion for Ohio. Math counts, if you've heard of it before, if you haven't heard of it before, it's a national middle school math tournament. It's actually the big one in the United States. He also coaches his local local math counts team. And he doesn't only do math, he also loves languages. But those are the 2 co-hosts that we have here today. And we also have me. What we usually find out is that the high school co-hosts are usually better at this than I am. But in any case, let's go ahead and get started. We're going to do questions 1 to 15. And just because the co-hosts are usually better at math than me, I will be the one who starts with question 1. How does that sound? I think I can do question 1. Let's see. So what's question 1? Question 1 says, what is the value of 8 times 4 plus 2 minus 8 plus 4 times 2? Oh, they look the same. It must be 0, right? Is that right? Is it 0? Oh, well, it's question number 1. It can't possibly be 0. So let's see. So what should we do? Yes, this has to be the hardest question on the test. I totally agree with all of you. So now I guess I have to actually do arithmetic. This is indeed quite difficult. So 8 times 4, is that 32? Yes, plus 2. And then minus, don't forget parentheses, 8 plus 4 times 2 is 8. I guess this is like a PEMDAS. Oops, that's not what I want. This is like a PEMDAS type question. But so what's the easiest way to subtract these? Well, okay, I want to have a little bit of a fun with subtracting them. I see 8 plus 8, that's 16. And somehow I happen to know that 32 minus 16 is equal to 16. So I hope the answer is 18. Let's see, is this right? I managed to solve a question. With that, let's pop it to our high school co-host. Let's go by alphabetical last name. So Jesse, how about you take the next one?
All right, so let's get started on question 2. This one says, a square piece of paper is folded twice into 4 equal quarters, as shown below, then cut along the dashed line. When unfolded, the paper will match which of the following figures? Okay, I really wish that I was taking this on paper right now, because then I would take a piece of paper, fold it, cut it, and see what happens. But we can't do that right now. So let's try and simulate it. Okay, so let's start with our little piece of paper right here. Our first fold is going to be in half going up. So that means this is just going to become one rectangle like that. Let's make it at a rectangle. Something you'll learn about me today is that I am not a great artist, but we survive anyways. Okay, now we have this one rectangle that's a mirrored image of the top and the bottom. Okay, now we're going to fold it in half one more time, and it's going to go into a square. Now, if we have it as a square, well, we're going to cut. We cut it right here. And if we cut it right there, we need to figure out what part of our big square right here is getting cut. So if we go back one step, then we'll notice that this square goes right here. But because we're folding it along this edge, it's going to go right here too. So this triangle goes right here. And it also goes right here. So that's one step down. Now we need to map this back onto our really big one. Now, because we were folding top to bottom, then when we have this little triangle on the bottom, it's going to get mapped over onto our bottom. And you'll see here, we've got what we just did right here. And now one more right below it. Okay. And if we do that, we get a hole that looks right like a diamond right in the center, which matches up with an answer choice. Answer choice E. And now I see Eddie and Professor Loh have some paper. So did you maybe confirm that for us?
Absolutely. So Jesse did a great job of, obviously I was lucky in that I have scissors and this thing to help me cut a square paper for me, but obviously we'll have this on the exam. But just to put into picture what Jesse just told us. So we first, as a problem has, we first fold it up, then we fold it over. Actually, wait, it's already this way. Okay, I fold it over like this, and then we cut the bottom right corner. So after doing that, should work out like this. And after unfolding, bam, it's exactly what Jesse has, a little square in the middle, or triangle cut out in the middle. And you keep unfolding, you get exactly E.
Amazing. Actually, I just have a random question. Eddie, are you still normally reversed? I just have a random question.
Yes, so this is my left hand.
Yes. So in that case, you have an extra challenge when you just did this, because I saw you just had to figure out left-right reversal. These are how we do all of our live streams. Okay, amazing. Eddie, I think you're next.
All right, on to number 3. All right, so wind chill. Wind chill is a measure of how cold people feel when exposed to wind outside. Good estimate for wind chill can be found using this calculation. Wind chill is equal to air temperature minus 0.7 times wind speed. I'm curious, is this true? If it is, it's very interesting. I did not know that. So from this equation, we know that temperature is measured in degrees Fahrenheit, so let's mark that. We know that temperature is in Fahrenheit, so sorry to all the other countries out there. And we know that the wind speed is measured in miles per hour. So right now, we are assuming that the temperature is 36 degrees Fahrenheit, so that's like 2 degrees Celsius, and the wind speed is 18 miles per hour, which I believe is like 25 kilometers per hour. Either way, again, we're using American units, unfortunately. So right now we're looking for which of the following is closest to the approximate wind chill. Well, since they give us 2 pieces of information, the air temperature in Fahrenheit and the wind speed in miles per hour, let's plug it in. So right now we're told that the air temperature is 36 degrees Fahrenheit, and we have to subtract 0.7 times our 18 miles per hour. And wait, we don't really have to do anything else because this is exactly equal to the wind chill. So we just have to approximate what 36 degrees Fahrenheit minus 0.7 times 18 would be. So let's estimate. Well, I know that for what we have here, 0.7 is greater than 0.5. So 0.7 is bigger than 0.5, which means it's more than a 1/2. So 0.7 of 18 has to be more than half of 18. In other words, 0.7 times 18 has to be more than 9, because 9 is half of 18. So we're subtracting more than 9, which means it's got to be lower than 36 minus 9, which is roughly 26. And then we know we have to subtract more because it's not subtracting 9, it's subtracting more than 9. So based off the answer choices, I need to subtract out a little more. And it can't be 36 minus 18 because 0.7 times 18 is not 18. So purely based off of estimation, we can assume it's 23.
Wow. That's pretty interesting. I didn't actually expect that to work, but this is actually a big time saver. I mean, 36 minus 9, that's 27, but that doesn't matter because that still does what you wanted.
Oh no!
It's okay. It still did what you wanted. It still did what you wanted. Yeah, you just used the answer choices. That's actually really interesting. Okay, because actually when I was looking at that, I actually just multiplied 0.7 times 18. But that approximation is pretty good. Jesse, did you have anything you want to jump in on this?
Yeah, I did the same thing. I saw a lot of people in chat did it too. I just multiplied it out, got 23.4. And you can either round or just see the closest answer choice is going to be 23.
Nice. Okay. Yes, I see that somebody has just put in that Eddie is a professional approximator. Very nice. Let's keep it going because we actually have 15 questions to go through. So we're going to go through, we'll go through relatively quick, except that we will explain everything. We will explain everything. Okay, so let's see. I've got something with the numbers from 1 to 49 are arranged in a spiral pattern on a square grid, beginning at the center. The first few numbers have been entered into the grid below. Consider the 4 numbers that will appear in the shaded squares. Actually, in my screen, it's not showing the shaded squares. So let me just shade them for you. They're going to look like shaded circles, but that's because my pen is round. But you want those 4 shaded squares? Yes, thanks for everyone for asking. We want to know, out of those 4 shaded squares, oh yeah, it says they're on the same diagonal as 7 too, by the way. Okay, how many of them are prime? Well, if I want to do this, I would say the pattern is not very easy because it kind of just keeps spiraling around. So I think I'm just going to start counting. I'm just going to start going around and counting. So, oh, maybe I'll do it this way. Just to save a little bit of work, I'll do some addition also. So what's going to go here? Can anyone tell me what goes here? So 7 plus 3, that's going to give me 10 because I went over by 3. Does that make sense? Go over by 3. And then let's see how much is on this corner. I go up by 3 again. So that's 13. Now, if I want to go from here all the way to there, I have to go up by 4, I think. 1, 2, 3, 4. 4. Yeah, I have to go by 4. So that's 17. Oh, but now I actually get to one of these shaded squares. And at this point, I see that the chat is covering. So I am going to move the chat just temporarily to cover that. Okay, so that you guys can keep talking, but we just keep going. So that's 17. Yes, I see that people already are telling me the shaded thing is a 19. Thank you. And then if I just keep going, this is a 21. That's a +2. Now, if I want to know what's here, that's another +2. So that's a 23. Then if I want to go all the way across, it's +3 more. That's 26. Oh boy, what's this? 1, 2, 3, 4, 5. So I need to go 5 squares up. That's 31. Then I need to go to the left. How many squares is that? 6 squares to the left. That's 37. Okay, now I need to go down by 2. That's 39. Let's make that 9 clear. 39. And then I need to go down by 4 more. That's 43. I'm going to keep on going all the way across. I want to make sure that I get to 49 at the end. So 43 plus 4 is 47. Oh, good. And plus 2 is 49. So I didn't make any mistakes. I have all of them labeled. And now, oh, I see some people are saying in the chat, no, 39 is not prime. It's 3 times 13. And people are wondering, is there a faster way? You just counted. I am basically just counting 2, but I'm just trying to write down fewer numbers. But anyway, of them, this is not prime. The 39 is not prime. And so the answer is 3 because there are 19, 23, and 47. Those are all prime. I think the answer is D, which is 3. Is it? Ah, it is D. That's right. Do my co-hosts have anything to add?
So I counted it in a different way. I like looking at the squares. So after the first number, that's just 1. And then right here with this 4, we complete a 2 by 2. And I note that the last number in a 2 by 2 has to be 4 because that's 2 squared. And so after I complete the 3 by 3, which is right here, I know that should be 9. After I complete the 4 by 4, that should be 16. So I first put in the perfect squares because, for example, at the end of the 6 by 6, that's a 36. And this actually makes counting the numbers really easy because, for example, the shaded square right next to the 7 is right here, which is also just 2 less than 25. So that's how you get 23. And then this one here is 2 less. I'm going to hide chat for just a moment. And this square over here is going to be 2 less than 49. So that's how you would get the 47. And you can, albeit this one is more complicated, same idea.
Oh, wow. That is much better. So this is, again, everyone, this is why I bring the high school stars onto this show. Cool.
I actually found them a slightly different way. So I did write out every number, But what I noticed afterwards is if you start at the end with 49, then you can go backwards from 49 up until your 39. And then from your 1 all the way up to 23. That way you can kind of skip all your mid 20s and 30s and just save a little bit of time like that.
That's also nice. Cool. Okay, thanks, guys. Jesse, maybe on to you.
All right, let's go to question 5. A lake contains 250 trout, along with a variety of other fish. When a marine biologist catches and releases a sample of 180 fish from the lake, 30 are identified as trout. Assume that the ratio of trout to the total number of fish is the same in both the sample and the lake. How many fish are there in the lake? Oh, I like this problem because fish. I don't know. I'm a big fan of fish. So let's kind of figure out if we're going to have the same ratio. That means we're going to have the number of trout in our sample over our number of fish in the sample. It's going to be equal to the number of trout in the lake over the total number of fish in the lake. Okay, so now we need to figure out what these two ratios are. Now let's plug in the numbers that we have. We get the number of trout in our sample to tell us that there's 30 of them. So 30. And the number of fish in our sample is 180. But with ratios, we do always want to simplify. So let's make this 1/6. Okay. So the number of trout to the number of total fish is always going to be 1/6. That's going to be really important. Now let's go to our other ratio that we have. The total number of trout divided by the total number of fish. And which of these numbers do we have? Well, we have 250 trout total. So that means we're going to have 250 over whatever we're going to be solving for. So let's just say, instead of using X, I'm going to use F for fish. Now this is going to be equal to 1/6. Now we can just use some ratio laws. We could multiply both sides by 6 and by F, just to simplify this a little bit. So if we do multiply by 6, then we get, well, 6 times 250 is going to be 1,500 divided by the total number of fish is going to be equal to 1, which means that the total number of fish, let's put it right here. The number of fish is 1,500, which is answer choice B. Let's circle that.
Perfect. I think that this problem is pretty cool. I think that it's a way, for example, if you wanted to estimate how many total fish are in the pond, this is a great way to do it. Just get a ballpark estimate. You don't have to be too exact. After all, I've made my name here today by estimating. So
Eddie the estimator. Yes.
perfect. All right. So moving on to number 6. Here we have the digits 2023, because it's the year 2023. They're placed in the expression below. So something to the power something times something to the power something. 1 digit per box. So what is the maximum possible value of the expression? Okay, so let's look at our possibilities. Right away, when I think about numbers, I could plug into the base of an exponent. I can either plug a 2, a 0, or a 3. But the problem is if I put a 0, no matter what I put there, it's not going to do anything, because 0 to anything except for 0, please don't. Okay, 0 to positive numbers are 0. So if I take 0 times something, that's literally going to be the smallest number we could possibly get. So let's not do that, which means we should put either a 2 or a 3 here. So what could we do? So I see another person in chat made the nice observation that 3 squared is greater than 2 cubed. And that's true. 3 squared is 3 times 3, 9. 2 cubed is 2 times 2 times 2, 8. So what this is saying is 9 is greater than 8. which means using the exact same numbers, 1, 2, and 1, 3, we get a bigger number by putting 3 squared. So I like that. Let's put a 3 here, which means we get 3 squared. And remaining, we have a 0 and a 2. So as we just mentioned, putting a 0 as the base completely kills the expression. So 2 to the 0 is better. And as a review, anything to the 0 power, except for 0 to 0, that's a little complicated, that's going to be 1. And a little like justification for why is just that if you think about, for example, 2 squared we know is 4, and then going down to 2 to the first power, I have to divide by 2. If I go up a power, it's multiplying by 2. If I go down a power, that's dividing by 2. So if I have to go down one more power, 2 to the 0, I have to divide by 2 again. 2 divided by 2 is 1. And that's the same justification you'd use for any number to the 0 power being 1. Awesome. So finishing off the problem, we have 3 squared times 2 to the 0. That's 9 times 1, which will give us C, number 9.
All right, yeah. The way I looked at this problem was I just wrote out every possibility because there aren't too many here. And I got all these different numbers. So now instead of figuring out where 0 would go first, I actually went and picked the largest number I can because we're going to be multiplying. So if we use the 3 to the power of 2 to get our 9, then let's put that in here. 3 to the 2. Now we have a 0 and a 2 left over. So now if we look at our two possibilities for doing that, we have 2 to the 0 or 0 squared. And of course, we're going to want the bigger of these, which is going to be 2 to the 0th, with the same answer that Eddie got of 9.
Yeah, very nice. Very nice. Okay, let's keep on going. I have nothing else to add here. This was great. Oh, what's this? So there's a rectangle with sides parallel to the x-axis and the y-axis, and it has opposite vertices located at 15,3, that's here, and 16,5, that's there. A line is drawn through the points 0, 0, that's A and B. Oh, so we're drawing a nice line here. There's a line going through here, and another line is drawn through these 2 points, going down to here. How many points on the rectangle lie on at least one of the 2 lines? Okay, I guess I need to know where these lines are going then. Let me start with this one. This one looks easier. So if I look at this line, can anyone tell me the slope? What's the slope? The slope is how much it goes up divided by how much it goes across. So what's the slope of this line? Oh, I see a lot of people saying in the chat, the slope of this line is it goes up 1 for every 3 that it goes across. Okay, so the slope is 1/3. Well, now my chat is covering things up, so I'm just going to move my chat. Famous last words. Let's get this. Yep, I'm going to move it all the way up here because we know the question now. So I want to know how this is going up. Oh, right. This is at 15. This x-coordinate is at 15. So rise 1, run 3. If it goes across by 15, how much does it go up? Can anyone tell me in chat? If it's going across by 15, how much is it going to go up? Well, it's 1/3 of the 15, right? The slope is 1/3. So it's going to go up 5. I see lots of people saying 5. So that means that when this line goes through, it's going to go through the point 15 and 5. Where's that? Oh my gosh, that's the corner. Ah, that's nice. The question is trying to be kind of tricky. So if I look at what's going on here, I'll just keep on going. Pretend that's a straight line, okay? Maybe sort of a straight line, but it goes through the corner, hits exactly once in the corner. How nice. How about the other line? Well, the other line is going to come down, come down. What's the slope of that line? Can anyone tell me? Well, as you can see, it's going down 1 when it goes across by 2. The slope is not 1/2. The slope is minus 1/2, right? Minus because it's going down. So then in that case, if it's going down, all right, so it's going down 1 every 2 it goes across. In that case, when this line goes all the way over to the x equals 15, how much has it gone down? So here's what I'm asking. When x equals 15, how much has the line gone down? Remember, it's going down by a slope of it's going by a slope of minus 1/2. So it's going to go down by half of that. It's going to go down by 7.5. So it goes to 10 minus 7.5, which is 2.5. Ooh, 2.5. Where's that? The bottom is at, the bottom's at 3. So that means that it's going to come down and just miss this completely. So let's try to draw this. By the way, drawing is very, very hard, but that looks sort of right. And so I see that the answer is, how many times does it hit? It just hits exactly once. So I think the answer is B, which is 1. And I'll give a tip. On the actual test, if you have it on paper, and if the paper test is in front of you, you can get a straight line by folding a piece of paper. And then you just put it there and you look. And that's a good way to check your answer. I think the answer is 1. Yay! The answer is indeed B, 1. Cool. Do my co-hosts have better ideas?
I don't know if I'd say it's a better idea, but something slightly different that I do, because like I said, I'm really bad at drawing, and that includes straight lines. So I got the same slopes, but instead of actually drawing out the lines, I just went each point that would hit on a coordinate point. So I went over 1, or up 1 over 3, or down 1 over 2. And then that way I'm only plotting the actual points, and then you can see where they intersect without having any messy lines all over the place.
Well, that's pretty good. And I saw that somebody said, oh, by the way, rulers are allowed on the AMC 8. Well, in that case, you can do what I'd see on Eddie's screen.
Yeah, I basically have the equivalent of a ruler. So what's nice about the pen is that I have a straight line tool. So obviously, if I try to hand draw this line, like I'll try my best. Oh no, like yeah, that didn't that went very off track very quickly. It's hard. So I'm lucky with that. But since you do have the ruler, you can use that. Another thing is that this rectangle almost matches up with my outlet in the background. So
very nice, very nice. Oh, somebody just pointed out that some people are doing it online and the question is on the computer. Well, in that case, what you need to do is you need to get your scratch paper, and you take your scratch paper, you fold it, and there's your ruler. This is a good thing now that we're using flat screen monitors. We're not in the 1990s when they had the nice round things. Anyway, okay, next question. Who's the next question? Not me.
Right.
I think it's
That
Jesse.
would be me. Yeah. Question 8. Oh, so close to getting it first try. Lola, Lolo, Tia, and Tio participated in a ping pong tournament. Each player competed against each of the other 3 players exactly twice. Shown below are the win-loss records for the players. The numbers 1 and 0 represent a win or loss respectively. For example, Lola won 5 matches and lost the 4th match. So now we want to find Tio's win-loss record. Now, I think the most important thing we can start with finding here is how many 1s and 0s, or wins and losses, we need every time. So if there are no ties, because the question kind of says there's only wins and losses, then every time, for every 1 win, that's not how you spell that. For 1 win, there's 1 loss. So that means that every time we do this, we're going to need to have 2 zeros and 2 1s. Now, if we just go game by game on what we have, we can figure out which one is missing. So let's do that one by one. First off, we're going to have Lola and Lolo both winning. So Tia and Tio are both going to lose. Give them a big 0. Next up, we already have 2 winners. So Tio's also going to lose this one. That's kind of sad. He's on a little bit of a losing streak. Game 3, same thing. We're going to lose again. All right, that's okay. Because on game 4, we only have 1 winner listed, and it's finally Tio's time to win. Give him a big old 1. All right, game 5, back to that losing streak. It's okay. It happens to everyone. Put down 1 more 0. And lastly, we're going to end this game on a high note, and we're going to win. So we should have 3 losses, a win, a loss, and 1 more win, which will go right with answer choice A. Right there.
awesome. Another thing is, the great thing about AMC is that since there are answer choices, if you want to save time, once you get those 3 losses, you might be able to see, well, wait. So once you get to 2 losses, you've narrowed it down to A and B, and then once you're at 3, you know it has to be A. So that saves you some time.
Answer choice Eddie. You're good at this.
Perfect. Yeah, I like to be lazier. Work smarter, not harder. So, if I can take a shortcut, might as well. All right. And also, I'm not sure if any of you guys watch League of Legends esports, but this is the exact format that they use for the World Championship. So that reminded me of that. All right, number 9. So Malaika is skiing on a mountain. The graph below shows her elevation in meters above the base of the mountain as she skis along a trail. So here we have the elevation in meters and then the time, how much time she's been skiing. So in total, how many seconds does she spend at an elevation between 4 and 7 meters? Okay, well, since we have an elevation of between 4 and 7, right away, my instinct is to, let's just mark what that is on the graph. So the graph lines are not showing up. Maybe if I make it bigger, they will. Okay, they're a little better, but I'm going to move this over. There we go. Then we can see the numbers. Okay, so between an elevation of 7 meters, I know 7 meters is right here. So drawing a line across, again, I'm lucky that, I don't actually draw the straight up lines, and then elevation of 4 is right there. Draw a straight line across. And we know that we want to know how much time she spends in between here. So we want to know for how long her elevation, aka her point on the graph, how much of it is in between 4 and 7. So I'm actually just going to trace what parts of the graph are between 4 and 7. So this part is definitely between 4 and 7. And then we have this part that's definitely between 4 and 7. And then finally this downward part that's going 4 and 7. Okay, so now that we have figured out which part she's at 4 and 7, what's the question asking for? So the question says, how many seconds does she spend? So now we just have to look at how many seconds this is. So in this first bit here, I see that this is between 2 and 4, which must mean this is 2 seconds. And then from this one, that looks like 6 to 10. This is going to be, chat, you guys are flooding my screen. Great to see so many answers. So 6 to 10 is going to be 4 more seconds. And then finally, I don't know where this line went. This last part is from 12 to 14, which is going to be 2 more seconds. And then, all right. Actually, I don't know if this is the line. I don't know if I should be counting because I got that part is not above. Yeah, that part is above 7.
Right. That part is above 7.
All right.
It's just on the diagram that you have on the screen, yeah.
So we're adding just 2, 4, and 2. So exactly what Kylie has on screen right now. 2 plus 4 plus 2 is 8 seconds, which going back to our answers is answer choice B.
Yay! Cool. Jesse, did you want to say anything there or should I just go on?
Yeah, I think you can go on. I don't have anything to add there.
Okay. Ooh. Harold made a plum pie to take on a picnic. He was able to eat only 1/4 of the pie, and then he left the rest for his friends. A moose came by. Is that one of his friends? Anyway, a moose came by and ate 1/3 of what Harold left behind. After that, a porcupine ate 1/3 of what the moose left behind. How much of the original pie remained after the porcupine left? I never realized that porcupines ate pies, but well, let's just do this problem. Maybe they do. Okay, never tried before. All right, so actually with this kind of question, this is asking how much remained. Whenever I see a question about how much remained, I like to multiply fractions. So originally there's just one pie, right? Like we have 1. That's originally. And then what happens next? Well, let me use the colors this way. So originally you have the 1. And then here comes Harold. Harold eats only 1/4 of the pie. I'm going to write how much is left. Maybe I want to emphasize that. This is how much is left. After Harold, if Harold ate 1/4, how much is left? Can anyone type into the chat? If Harold eats 1/4, how much is left? What fraction is left? Here it comes. Yes, 3/4 is left. And that's after Harold. Okay, and then the next thing that happens is that his friend the moose shows up, but we keep multiplying because we want to know how much of this is left. Well, the moose ate 1/3. If the moose eats 1/3, what fraction? If moose eats 1/3 of something, what fraction of the something is left? I'm talking about when you take away 1/3 of something, the fraction that's left is 2/3 of it. Okay, and so it's times 2/3 because whatever happens after the moose, after the moose is that it's 2/3 left of whatever was left before. This is why it's nice. We could just keep multiplying the fractions. Then the porcupine shows up. Okay, the very hungry porcupine. Porcupine, what number do I multiply now? Porcupine eats 1/3, so the fraction that's left, well, the fraction I multiply by is 2/3, because that's how much is left after the porcupine. Now we just multiply. I see a lot of canceling. I see that the 2, 2, and the 4 cancel. And I also see that I can cancel some 3s. It looks like the answer is just 1/3 of the pie left over. So I'll go with D. Is that right? Yes. Okay. Meanwhile, I see that my co-hosts have drawn interesting things.
Yeah, what I did was, now you can't exactly get the answer like this unless you're really good at drawing fractions. But if you can estimate them, then you can write out or kind of draw out how much has been eaten in each turn. And then you can use what you see left and kind of see if your answer is about right based on how much is left. And this does look like about 1/3 of it. And that's just some way that you can reaffirm your answer. Oh, Eddie, I think you have something to say?
Yeah, perfect. So I took it step by step. So first, Harold eats his quarter, and then there's 3/4 left for the moose. Divide that into 3 parts for the moose to take 1 part, and then half of the original circle is left for the porcupine. Take out 1/3 of that, and you're just left with this portion, which definitely looks like 1/3. Although this relies on good drawing skills, so if you don't have that on the exam, I think going the fractions is definitely the surefire way to go.
Cool. Okay, let's go on. I think Jesse is next.
Yes, I am. So now we're going to go into NASA. So NASA's Perseverance rover was launched on July 30th, 2020. After traveling 292,526,838 miles, it landed on Mars in Jezero crater about 6.5 months later. Which of the following is closest to the rover's average interplanetary speed in miles per hour? Now, this seems like a really cool estimation problem that I'm kind of stealing from Eddie. So let's kind of see how we can get started. And the first thing we should notice here is how far apart the answer choices are. We've got 6,000, we've got 12,000, we've got 60,000, we've got 120,000, and we have 600,000. So it's really awesome that these answer choices are so far apart because we can use different numbers than they give us in the problem to kind of estimate it. So the first thing that we want to do is, if we want miles per hour, then we need miles divided by hours, but we don't have hours, do we? So what we're going to do is, if we have months, this is going to be equal to miles over months times days in a month times hours in a day. So a lot more multiplication than we would have had to do if they could just give us those stinking hours. And to approximate this, well, we don't want to use 292 million, blah, 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 because, well, if we approximate it, we can use 300 million. It is pretty far off, but the difference between 300 million and 292 million really isn't that big in the grand scheme of things. So let's put 300 million right there. And now they give us 6.5 months, but 6.5 is kind of not a good number because that's a decimal. And 300,000, well, I see a 3, which usually indicates a multiple of 6. So we'll use 6 months Now we need the number of days. Now this does vary month by month, but on average, a pretty good estimate is 30 days in a month. And now we need the number of hours. I think we can all say there are 24 hours in a day, but 24 is a lot worse for multiplication and division than 25. So we're going to say there's 25 hours in our super special days here. So let's start and estimate this division. Now, if we have 300 million, I'm going to start by dividing it by 30. So if we divide by 30 first, that's going to give us, the threes are going to go, and that's a 0. So that should give us 10 million. So now we have 10 million divided by 6 times 25. So why are we multiplying by 6 instead of 6.5? That's because we're estimating here. So 6 and 6.5 are really close. So we can actually just use 6 instead, and it's a better number to divide by. Yeah, so now we have 10 million divided by 6 divided by 25. Well, we're going to divide by 25 first. So this is going to leave us with, I can't do this one in my head, 10 million divided by 25. Oh, there's going to be 4 in there, and that's going to leave us with a bunch of zeros. So 400,000, I believe. 400,000 divided by 6. Now, this is not too great to divide, but if we do the 2 first, then we get 200,000 divided by 3. All right, so we're not going to keep going. We're going to take a look at our answer choices now. If we look at our answer choices, which of these is about 1/3 of 200,000? Now, we know right off the bat, it's not 600,000 because that's greater. Let's knock that off. Now, 120,000. Well, that's more than half of 200,000, so it's not going to be that one. And next we have 60,000. Well, 60,000 is 1/3 of 180,000, which is slightly less than 200,000, which means that we don't want to go any further below 60,000. And a pretty good estimate of the miles per hour that the Perseverance rover traveled is going to be 60,000 after lots of division.
Yes. So I know thinking about 25 hours in a day is really weird, but as Jesse said, it makes the multiplication a lot easier because we rounded everything pretty reasonably. We didn't do some crazy rounding because look at how far apart the answers are. 12,000 is twice 6,000. 60,000 is 5 times 12,000. And then this is twice C, and E is 5 times D. So if we were to round so hard that we rounded ourselves to the wrong answer, we would have to had rounded a total factor of 2. That's like saying we rounded like 25 to 50, which that's not rounding at that point. That's just making bigger numbers for fun. So, all right. And then another note is that in science, the best part is that the units always work out. So after all this crossing out, you'll end up with miles per hour. And this should happen for basically everything. And so it's a great way to check your answer. And also like a sanity check. You have like miles per hour and not like, some other unit. All right. We got a figure with a large unshaded circle. So the big one is unshaded, and then a number of small unshaded and shaded circles in its interior. So let me color in blue what we have shaded so far. So we have this thing, all right, and then all the tiny circles over here are shaded as well. Not doing the best shading job, but you guys get the gist. So this part shaded as well. All right, so what fraction of the interior of the large unshaded circle is shaded? So in other words, we want to know the total shaded over the big circle, the biggest circle, if we will. Okay, so let's start by, I believe there are grid lines. So they don't show up that well on my screen, but here, I'll do this. I believe maybe I might just have to draw them on my own. So what we have here is that it doesn't tell us the radius or the exact length of anything. Instead, we can use ratios. So what it tells us is that this length, so the diameter of this circle is the same as the diameter of this circle, which is also this green length here. So all these green lengths are the exact same, which means we can say that, okay, how do I call the circles? Maybe we'll call the circles A, B, C, D, and then A is the biggest, D is the smallest. So since these green diameter circles are the second smallest, I'm going to call them circle C. And actually, I'm going to color this green in that case. So knowing that, let's also mark the grid lines for the tiniest circle. So the tiniest circle is exactly half. So this diameter is exactly half of the green line. So I can split this green segment into these two smaller red segments, and they're the exact same. So I'm going to make that D. Okay. Yes, there is a grid. Unfortunately, it doesn't show up here. But what we can do now is set up some ratios. So here's the thing. Even though it doesn't give any lengths and it's only asking for ratios, what I would love to do is give it a value. So what do you guys want the entire green length to be from here to there? So give me a number, and it would be great if it was a nice number. What is a nice number? Well, see if you can use good judgment to figure out what would be a nice number. Okay, another person says 6, and so does YN11. So I agree, because first of all, not only are there 6 spots in the grid line, but it also makes dividing super easy. What setting the big green length as 6 does is that, so the big green is 6, it makes each of these green segments 2, and then these red segments 1, each 1. These are all nice numbers to deal with. So from there, now let's just calculate areas. So what we need to do is find the area of, well, we need to find the area of the big circle because we'll need that to divide at the very end. And so we take the radius, which is going to be half the diameter of 6, which means the radius is 3, and we know that area is equal to pi r squared. So the big circle is going to be A, which is pi times 3 squared, which is going to be 9 pi. So the area of the big circle is 9 pi. We're looking for the area of the shaded area. We're looking for the ratio of the shaded area over the big circle. Okay, how would we go about finding the shaded area here? So inside circle B, the second biggest, but outside of the third biggest, circle C. How would we find that one? It's really, really weird. This shape, this little, I don't know what you would call this, but exactly what another person says. It's take the big circle and subtract out to 2 smaller circles. Even though it's a weird shape, this describes exactly what it is. It's a large circle minus 2 circles inside. So we know that circle B has radius 2. So since this has radius 2, its area is going to be pi times 2 squared, which is going to be 4 pi. And then the area of the green circles, we want 2 of them, right? So 2 times the area of one green circle is going to be 2 times pi times the radius. Since the diameter 2 is 2, the radius is 1. So 2 pi 1 squared. So that means this is going to be 2 pi, which means the area of this shaded part is going to be 4 pi minus 2 pi, which is 2 pi. So 4 pi minus 2 pi equals 2 pi. Finally, don't forget that these 3 smaller circles are shaded as well. So we just have to find the area of one of them multiplied by 3. Since its diameter is 1, the radius is 1/2. So we would say that the area of that one would be, I'll write it up top here, A is equal to pi r squared again, but now we know that r is equal to 1/2. So 1/2 squared is 1/4, and you get 1/4 pi. And so 3 of that is going to contribute an extra 3/4 pi to the shaded area. So we got the 2 pi from here, and we also get 3 times 1/4 from there. Okay, this is getting a little cluttered, so I'm going to move it a little. Now the final thing we have to do is just find what this ratio is. And so combining the top, we get 8 pi plus 3 pi, which is going to be combined 11/4 pi over 9 pi. The pi's cancel out, which is splendid because that's a weird fraction to have. And then you get 11/4 divided by 9. So I'm getting 11/36. And let's check if that's an answer choice. And lucky enough for us, it should be right. Answer choice B.
That was a really good way of doing it. I think the one thing I did different was when Eddie set that radius or the overall diameter as 6, I actually set it as 12 because you guys can't see the grid, or maybe you can see the grid lines now, but you'll notice there's only one grid line going through these small circles. And if we make it twice as big, then instead of having to deal with these fractional radii, then we can actually make them 1. And then another thing I noted at the very beginning was because we're looking for a ratio here, then we can ignore pi the entire time because like Eddie canceled it out at the very end. If we do a ratio, then it's going to be the area divided by another area and both will have pi in them and they'll just cancel out like they never even existed.
Yeah, these are pretty good ideas. I mean, like the idea of trying to cancel out the pi. I saw somebody ask, you assume they're all squares. I'm not entirely sure that's safe because the shapes might be a little weird. I mean, when I'm looking at this and also with the advantage of not having to be on the spot while doing it, if I was thinking of everything just in terms of ratios, there's something you can do, which is that if this little circle is 1/6 of the big circle, what's the ratio of its area? So if I can say the diameter even. So I'm not even going to say how long each of the diameters are. Like if this is 1/6 of that diameter, then what happens to the area? The area is not 1/6. The area is you square it, so it's 1/36. So actually each of these is 1/36. Could that be useful? Well, that's pretty good. I got 3/36 so far. The answer we remember was 11/36. So then I've got this piece over here. And there's something else that's nice about this picture. You may have noticed from Eddie's calculation, but whenever I have a picture like this, actually the shaded part is half of the area of this intermediate circle. If you haven't seen that carefully before, I recommend you try it, but this is a common picture where you have this circle and this circle, which are both like half of the diameter. The diameter is half the diameter of this intermediate circle. Okay, well, if the shaded part here is half, well, that's the same as those two. So then the answer is the same as if I wanted to know the fraction where these are the shaded ones instead. Aha. Well, if I want to do that, these I can do the ratio again. If the diameter is 1:3 between this circle and the big one, then what happens to the area? If this is 1/3 of the length, what is the fraction of the area? What do you do with the 1/3? Oops, wrong pen. That gives you more time to answer. What happens to the area? So I'm saying that this diameter is 1/3 of the diameter of the whole thing. And so the ratio of the area of this piece to the area of the whole thing is the square of 1/3, which is 1/9. And if I want to put everything over a common denominator, let's turn the 9ths into 36. And that's 4. So that this gives you the same answer, actually, because you got 4/36, 4/36. That's 8 of them, plus 1, plus 1, plus 1, that's 11. But these are just different ways of doing the same question. Okay. I think I have the next question. So let me just do the next one and let's keep going. We're going a little bit over time, but we're going to finish 15 questions. Okay. Ooh. Along the route of a bicycle race, 7 water stations are evenly spaced between the start and the finish lines, as shown in the figure below. There are also 2 repair stations. I guess they're not drawn. 2 repair stations, and they're also evenly spaced between the start and the finish lines. And the 3rd water station is located 2 miles after the first repair station. how long is the race in miles? Oh, okay. I see that somebody has already put into the chat 8 gaps and 3 gaps, right? Even though there are 7 water stations, there are 8 gaps. So if I was thinking of what fraction of the way along, I guess water is blue. So I can say that this water station is at 1/8, that's at 2/8, and so on. And the last water station is at 7/8, and this is the fraction of the whole. So in that case, where's water station number 3? Well, that's the fraction 3/8. This is where water 3 is, okay? And blue stands for water. Now I also have the repair stations. Repair, I guess when you repair something, you use green. Green sounds good. It's like health. So if I put the repair station, where's the first repair station? Can anyone tell me the fraction of the way from start to end that corresponds to the first repair station? There's 2 of the repair stations. So it's at 1/2, right? No, it's at 1/3. Okay, so the first repair station is here at 1/3. Oh, neat. So I know that this gap here is 2 miles. What should I do with those fractions? So I've got a 3/8, I've got a 1/3. Those are fractions of the whole. And somehow the conversion into actual distance is that whatever that tiny bit there is, that's 2 miles. Can anyone tell me a good thing to do with the fractions 3/8 and 1/3? Those are fractions of a whole. So if I want to know what fraction of the entire distance they are apart, we can subtract them. How in the world did you make fractions appear? You have mad skills. Okay, so if I want to know what fraction of the whole, right? The fraction of the whole between is going to be 3/8 minus 1/3, which is over a common denominator, 9. So 8 times 3 is 24, 3 times 3 is 9, and 8. Oh, neat. Now, if 1/24 of the whole, if that is 2 miles, can anyone tell me how long is the whole? The fraction of the whole in between this is I heard somebody say, so please type into the chat. Actually, if you're new here, type the chat, send a message to chat relay. Maybe you're wondering how everyone else is able to talk. Send messages to chat relay and your messages will appear here. So if 2 miles is 1/24, the answer is 2 times 24, 48 miles, I think. Yes. Cool. Did anyone have anything to add, or do you want to just go right on?
No, I think that was a really great way of doing it. I didn't have anything else. So unless Eddie does, then we can go on to question 14.
Let's move on.
All right. So Nicholas is planning to send a package to his friend Anton, who is a stamp collector. To pay for the postage, Nicholas would like to cover the package with a large number of stamps. Suppose he has a collection of 5-cent, 10-cent, and 25-cent stamps with exactly 20 of each type. What is the greatest number of stamps Nicholas can use to make exactly $7.10 in postage? And now they're going to give us a little note here telling us, well, how many dollars there are in or how many cents there are in a dollar. Okay, so now what I want to do here is instead of dealing with cents, I'm actually going to deal with coins. So a 5-cent coin or 5-cent stamp, we're going to call this N for nickel. The 10-cent will be D for dime. And 25-cent is going to be Q for quarter. Same amount of money, same thing. So here we go. Now this is going to be our T. I'm going to make a little table here so we know how many of them we have and then how much money we have from each. So I'm going to put T for the type of coin, and we know our 3 types are N, D, and Q. And then we're going to have the number of each coin, and we want to maximize this number. And now finally, we need to know the total amount of money that we have. And it's important to know that at the very end, we need to have exactly $7.10 when we add these up. So if we want to find the maximum number of stamps that we can have, then what we need to do is take as many small stamps as we can, because every 5 nickel stamps is equal to 1 quarter stamp. So if we get more nickel stamps, then we get more stamps overall. But we're limited on how many we can have. If we have 20 stamps of each kind, then let's just start there. If we have 20 5-cent stamps, well, 20 times 5 cents is going to be exactly $1. That's not anywhere near our $7.10. So let's add in some dimes. There we go. Another 20 would give us $2. Now we have $3 in total, and we need another $4.10 made out of just these 25-cent stamps. So how many stamps can we use? Well, 8 quarter stamps, that's 8 times 25 cents, is going to give us $2. So that's not going to be it. We're looking for 4. So every 4 quarter stamps we have is going to be $1. And the closest we can get here is 16. But that only gives us $4, right? We're still 10 cents short, and there's no way to get that. So what we need to do here is add in 1 more quarter, even though it'll take us a little bit over. Now we have a total of $7.25, but we need to go down to $7.10. So how can we make back our 15 cents using the fewest amount of stamps possible? Well, we have a nickel for 5 and a dime for 10. So let's take both of these down to 19. There we go, 19 and 19. So now we have $1.95 right here. And sorry, that's just 95 cents. And $1.90 made out of our dimes. And now when we add these up, we're going to get exactly $7.10. But the question isn't asking how many of each kind. We need the total number of stamps that we can use. So we need to add up our numbers that we just got. 19 plus 19 plus 17. This is going to be 38 plus 17, which is going to give us 55. Now, that should be our answer because it is an answer choice. So let's check. Now, right here, there we go. It's E. Awesome.
Cool. For this type, yeah, just think about want as many coins as possible, so logically you would start from the smallest one. I think Jesse did it the most organized way you could, so make sure you just don't get lost in the problem, and you should be able to get it. All right, good to move on. Let's go on to number 15, final one. So Wiswam walks half a mile to get to school each day. His route consists of 10 city blocks of equal length, and he takes 1 minute to watch each block. Today, after walking 5 blocks, so 1, 2, 3, 4, 5, Wiswam discovers that he has to make a detour. So city's doing construction, sidewalks closed. Got to move around and walking 3 blocks of equal length instead of 1 block to reach the next corner. In other words, normally he would move this white length, which is 1 block, but he has to go these 3 red lengths for the detour, right? So 3 blocks instead of 1 block to reach the next corner. From the time he starts his detour, at what speed in miles per hour must Wiswam walk in order to arrive at school at his usual time? Okay, so here's the thing. We know that the problem is half a mile. So from his starting point to school, that's way too big. Let's shorten that a little. So the cumulative length, the total length of all 10 blocks is 1/2 mile, right? So this is half a mile, and it's equivalent to 10 blocks. 10 of these white lengths. So imagine if I kept copy pasting and just, his normal path would be 1, 2, 3, 4, 5, 6, 7, 9, 8, 10, right? 7, 8, 9, 10. Okay, so that's 10 blocks. This is the normal route. So normal day, 10 blocks. But again, here, instead of walking 10, he's walked 1 less here. So he's walked 9 of the white lengths, if you can imagine to fill in the rest, but 3 red lengths. So he's walked 2 more blocks than usual. You can kind of think about just he's walked these 2 extra vertical lengths. So this yellow 10 blocks is normal walk, but today, because of the detour, he's gone 12 blocks. So he's walked 12 blocks. No matter how long a block is, 1 block is the same as any other block. So basically, these 10 blocks are the same unit as these 12 blocks. So I don't care how long a block is. We can think about it as he walked 12 over 10 of his normal route. So normally he walks 10, but now he walks 12 over 10 as much, which is 6/5 as much. So he has to cover 6/5 of his normal distance, but has to go his normal time. So let's illustrate this. So he is going 6/5 of the distance, but he wants to keep same time. So now the question is, at what speed does he have to walk?
Eddie, by the way, I think the question has a tricky piece in it where it says he only discovers he has to change his speed halfway.
Oh,
No problem.
it's not that simple. Okay, that is an important detail. So we have to divide this into steps then. Thank you for the catch, Professor Loh. So that means right here, it's only at this point that this one's like, hold up, I need to go around. So right at this point, which means he's gone this at the same speed as he normally does. So now we can assume, since the first leg of both trips are the exact same, so the first 5 blocks of the normal route and the first 5 blocks of the detour, same length, same speed, so therefore the same time. The only thing that's changed is that in the second leg, so half of the half mile, which means this length is 1/4 of a mile. In 1/4 of a mile, normally he walks 5 blocks. But now he walks 7 in total, right? So 1, 2, 3, 4, 5, 6, 7. 7 blocks. So normally on a normal day, he goes a distance of 5 blocks. And now because of the detour, he's going 7 blocks. So, we know that this distance is 1/4 of a mile from our diagram. And so let's do this. Because both of these routes take the same time, he's walking 7/5 of the distance, but that means he has to walk faster to compensate. So that way the trip can last the same time. So if he goes 7/5 of the distance, he needs to go faster, which means he needs to go 7/5 of the speed as well. You have to go faster in order to go a longer distance at the same time. So whatever speed this was, he needs to walk 7/5 of that speed. Okay, so now our job is calculating that speed. So what is that? Well, we know that his speed is 5 blocks, which is 1/4 of a mile. And how much time? We have to go back to the problem for that one. So normally he goes half a mile, which means each block is 1/20th of a mile. And he takes 1 minute to walk each block. That's the important part. So right here, since he takes 1 minute to walk each block, this took 5 minutes. 5 minutes. So 5 minutes at 12 miles, 5 minutes at 1/4 of a mile would mean, well, how many 5 minutes do I have in an hour? I have 12. That's where I slipped and got the 12. So to get my speed in miles per hour, I need to do this 12 times. So his speed is 12 times 1/4. 12 times 1/4, which is 3 miles per hour. And now he needs to go 7/5 of that. So 7/5 of 3 miles per hour is going to give us, we're going to have to do a little estimating, but hopefully the problem can help us out. So 7/5 over 7 times 3 over 5 is 21 over 5. I know that's over 4, so let's look at the answer choices. Are there any of them that are slightly more than 4? And yes, 4.2 works out perfectly. And dividing by 5 is really nice because we can multiply the denominator by 2, and then we get something in 10, which is literally the nicest we can get. So if we multiply this by 2 over 2, we get 42 over 10, which is definitely 4.2. So we can be pretty confident that our answer is B, 4.2.
Yeah, something I noticed that it's actually really nice, the test writers, because Eddie, I did the exact same thing as you and thought he was going that speed the entire time. And they actually didn't make that an answer choice. So if he had noticed, or if he hadn't noticed until like the very beginning, and he walked that for 6/5 as far, then, well, even if you fell for that trap, you wouldn't have had to pick a wrong answer choice. You would just be really confused for a second. That was really nice of him.
Cool. I wanted to add one thing. Again, I had the benefit of retrospect, but if you look at the answer, there's a 7. You had a 7 somewhere, right? So what you actually ultimately did is you took 7/5 times the original speed. But when you look at these answer choices, only one of them has a factor of 7. I'm being estimating, not really estimating, but using answer choices now, right? Because what do I mean by factor of 7? Well, this is like 4. This is like 42. 42 is a multiple of 7, and the others aren't. What do I mean by that? Well, what is the original speed anyway? Whenever we calculated the original speed, what did you guys use? I mean, the kinds of information that you used were half a mile. You used 10 blocks of equal length. You used 1 minute and walked 5 blocks. Oh, 5 blocks is not part of it because that's not part of the original speed. So I'm just looking at the information that's used to calculate the original speed, and there's like 60 minutes in an hour. There's no 7s. So I'm just like, the original speed, when you write it as a fraction, this is just going to end up being, when you write the whole thing as a fraction, this is just going to be 7/5 times some fraction, something divided by something. But nothing's going to cancel your 7. So what you're going to end up with is going to be multiple of 7 divided by whole number. And of the answers, there is only one of them that has it. So I guess this would be a shortcut once you realize 7/5. I'm using Eddie's trick. Okay, well, actually, that finishes our whole live solve. That's question 15. So we hope that you had some fun today. The way that we do all of these, oh yeah, I should probably put this on. Looks like we've got a last slide here. So yeah, hope that you like this today. And if you like this, we actually do run these live solves quite regularly. In fact, maybe you already know us on this YouTube channel from it. Oftentimes, I'm actually not the one who's here. And as you can see, the people who actually do it really know their stuff. Oh, somebody's asking, is there another one coming for the next 15? Well, actually, no, because that already happened. And if you look on our YouTube channel, you'll be able to see the old ones. But we actually are constantly running these kinds of live solves. And if you like learning in this way, we actually also, some people had asked, I saw somebody ask in the YouTube comments, do you guys run online preparation classes? The answer is yes. Actually, if you like learning from the teaching style that Jesse and Eddie was showing, we have systematized this into a way to learn how to think creatively about math. This is also why we use the chat relay, because we wanted to make it so that whenever we teach a class, it can always have people interacting like this. We actually like to have a lively class. So if you like this, just come join us. We have lots more. With that, it was nice to meet all of you. Always nice to meet another person. Have a good night, everyone. Bye-bye.
Thanks
Bye.
everybody for coming. Bye-bye.